This question was asked in the GATE Physics paper 2020. This is a numerical answer type question having 2 marks, and the topic of the question is electromagnetic theory. The question is, a plane electromagnetic wave of wavelength lambda is incident on a circular loop of conducting wire. The loop radius is small a, where small a is very less than the wavelength lambda. The angle in degrees made by the Poynting vector with the normal to the plane of the loop to generate a maximum induced electrical signal is, so we have to find the angle made by the Poynting vector with the normal of the plane of the loop to generate a maximum induced EMF. Let us see how to solve this problem. Let us consider a small loop having radius small a lying in the xy plane. The normal to the plane of the loop is along z direction, and that is denoted by n cap. Now the magnetic field vector, that is B vector, of the incident EM wave on the loop is making an angle theta with the normal to the plane of loop. According to the Faraday's law of electromagnetic induction, the induced EMF is given by E equals to minus d phi b dt, where phi b is the magnetic flux, that is denoted by surface integral of the magnetic field vector, that is B vector. So induced EMF E is equals to minus d dt of surface integral of the magnetic field vector, that is B. We can write this induced EMF as E equals to minus of surface integral del B del T dot product with the elementary surface vector, that is ds vector. Now n cap vector is along the ds vector, so we can write it as minus of surface integral of del B del T dot product with n cap times ds. So if we just write this dot product in terms of the magnitude of these two vector and angle between them, then we can write it as E equals to minus of surface integral del B del T ds cos theta, where theta is the angle between this V vector and n cap vector. Now if we have seen the expression for the induced EMF generated by the EM wave on a loop, then we can see to generate the maximum induced electrical signal, that is EMF, the angle theta should be 0 degree. That means the magnetic field should be parallel to the n cap, or 180 degree, that is the magnetic field is anti-parallel to the n cap, so that the magnitude of the induced EMF will be maximized. Then in that case cos theta will be either 1 or minus 1. Now if the magnetic field vector B is along parallel or antiparallel direction with the normal to the plane of the loop, the electric field vector of the EM wave will be in the xy plane, that is in the plane of the loop, since the electric field vector and magnetic field vector is mutually perpendicular for a TEM wave, that is transverse electromagnetic wave. So till now what we have seen, our magnetic field vector is along the or antiparallel to the normal to the plane of loop, and the electric field vector will be in the plane of the loop. Now Poynting vector for an EM wave is given by S vector equals to 1 by mu naught times E cross B. Now if we consider the magnetic field vector is along n cap direction and our electric field vector in the xy plane, then E cross B will also be in the xy plane, and that will be same case if our magnetic field vector is antiparallel to the n cap direction. So S vector will be in the xy plane, that is in the plane of the loop. Hence S vector will make 90° with the normal to the plane of the loop to generate a maximum induced EMF. So we have solved this problem and we found that the angle in degrees made by the Poynting vector in the normal to the plane of the loop to generate a maximum induced electrical signal, that is induced EMF, is 90°.